For thousands of years, people have believed that life follows an unchangeable path: birth, growth, aging, death, a natural law that no one can escape. But today, more and more scientists are asking a bold question: what if aging itself is a biological process that can be measured, understood, and perhaps even slowed down? For more than a century, medicine has studied diseases one by one: cancer, diabetes, heart disease, Alzheimer's disease. But scientists gradually began noticing something surprising. These seemingly different diseases may share a common upstream driver. That driver is aging. And that led to a new question. If we could slow aging itself, could we reduce the risk of many diseases at the same time? A major turning point in aging research came from a series of landmark discoveries. In 2013, scientists first proposed a unified framework for understanding the biological hallmarks of aging. Then in 2023, a landmark review published in Cell, Hallmarks of Aging, an Expanding Universe, expanded and refined that framework even further. Scientists began to see aging not as a vague concept, but as a biological program with identifiable mechanisms. In the past, people could only see the outcomes of aging: gray hair, wrinkles, disease. But now, scientists can see some of the underlying mechanisms: accumulating DNA damage, declining mitochondrial function, chronic inflammation, the buildup of senescent cells, stem cell exhaustion, and many other interconnected biological changes. By 2023, the framework had expanded to 12 hallmarks of aging. For the first time, aging became something that could be measured, studied, and potentially influenced. If aging has identifiable mechanisms, then a new question naturally follows. Can those mechanisms be slowed, or even partially reversed? Over the past decade, top scientific journals such as Cell, Nature Aging, and Science have published a growing number of studies exploring these possibilities. Scientists are investigating how to reduce age-related inflammation, improve metabolic health, and slow the progression of biological aging. Aging research is moving beyond simply describing what happens. It is entering the era of searching for interventions. Traditionally, medicine has focused on treating disease after it appears, but the future may look very different. Exercise, sleep, nutrition, metabolic health, and an expanding range of new interventions. The goal is no longer just to treat illness. It is to slow the biological processes that make illness more likely in the first place. Have you noticed that? Recovery takes longer, sleep feels lighter, energy levels decline, body fat increases more easily, memory doesn't feel quite as sharp. Most people would simply say, "That's just getting older." But scientists are beginning to see another possibility. These changes may reflect differences in how quickly our bodies are aging internally. In other words, two people can both be 40 years old, yet their bodies may not be aging at the same pace. And that is why more and more scientists believe that one of the most important medical revolutions of the 21st century may not be curing a single disease. It may be understanding why we age in the first place, and why some people seem to age faster, while others age more slowly. Next episode: what is biological age? Why can two people who are both 40 years old have body ages that differ by more than 10 years? Stay tuned for Research Friday number 2.